Good morning, ladies and gentlemen. My name is Gordon Zulu. Today I will be taking you in annuities. So to start with, we'll firstly discuss what annuities are. By definition, an annuity is a written contract typically between you and a life insurance company in which the insurance company makes a series of regular spaced payments to you in return for a premium or premiums to be paid. An annuity is not life insurance. What do we mean? Remember, when we talk about an annuity, you look at different kinds of annuities, but a life insurance policy that provides or rather benefits you and the family only if you die. That's what an annuity is. So immediately you look at an annuity. An annuity is a series of equal deposits or withdrawals made at equal intervals of time. For example, if you deposit a 2,500 each year for 20 years towards a pension fund, if the deposit is made at the time of compounding, then an annuity is called an ordinary annuity. So we'll look at ordinary annuities, which are divided into several sections. Under ordinary annuities, you will find what is referred to as future value annuity, present value annuity, and you will also look at what is referred to as debt repayment together with the sinking funds. But how do you differentiate these? When you are looking at what is referred to as the future value together with the present value, each and every equal deposit or withdrawals are made at the end of a particular month or year, or due to the number of compounding styles you have been given. You can have quarterly, semi-annually, biannually, it depends. Then aside from that, again, you have what is referred to as the debt repayment annuity, where you look at the scenario where you borrow, or rather a financing lending institution gives you money, and that money is what is referred to as the mortgage or a loan. Then aside from that, we will also look at what is referred to as a sinking fund, where a sinking fund, this is money that is being kept separate each year at the start, where you want either to replace a lost machine, or rather you want to replace a machine which is out of date. So that's what we are going to look at under these annuities. So to start with, I will firstly solve a certain example under future value annuity. So we have a question there which reads to say, to provide for future education costs, a family considers various methods of saving. Assume saving will continue for a period of 10 years at an interest rate of 7.5 per annum. So we have the first one there which reads to say, calculate the value of the fund at the end of 10 years when a single deposit of 2,000 is made annually. So with the future value annuity, we know to say, when we deal with this topic, we mainly consider the English that is being used. So you need to typically understand what the question is saying so that you comprehend before you start solving. So I will firstly give you the formula for future value annuity, and I will explain how each and every component in it works. So this is the future value annuities formula, where you have FV to be the future value, A naught to be the amount that you will be either depositing or withdrawing to meet a certain target that is specifically in the future, where R, this is the rate that you will be given in order. Remember, when you talk about 1 plus R, this is what is growing to the power number of years you are going to invest in the bank. Remember, this is what is growing exponentially when you are looking at what is referred to as the growth decay. And this is the R, which is also the rate. Then, when we deal with this formula, we can also expand this formula by writing FV is equal to A naught 1 plus R over M TM minus 1 over R over M. The reason why we have decided to put this, remember in the definition at the start, we said that we have what is referred to as compounding, which brings us to ordinary annuities. So this M is the compounding of days, quarterly, biannually, semi-annually, and the T is the number of years you are going to invest your money in the financing institution which you are going to save with. Maybe specifically in this case, we can talk about the bank. So we are going to first answer the first question, which says calculate the value of the fund at the end of 10 years when a single deposit of 2,000 is made annually. So how do we go about this? So remember here it says calculate the value of the fund at the end of 10 years. So we are looking at the fund at the end of a year. So we are calculating the future value in this case, where 2,000 is the annual, the amount that you are going to deposit each and every year in the bank for a period of 10 years. So we know firstly to say this is our formula, which is given by future value is equal to annual 1 plus r to the power t minus 1 over r. So this is the formula where we know to say the annual is the amount that we were given in this case, the annual being 2,000, and the rate, we were given the rate to be 7.5, which we change to a decimal by dividing it by 100, giving us 0.075. Then we know to say the time that was stipulated in the question is a period of 10 years minus 1, dividing this with 0.075 being the rate. Then from here, we can do our mathematics. So immediately you punch this, you will get your answer to be 2.0610 minus 1 over 0.075. Then from here, you can subtract this. Immediately you subtract. So immediately you subtract this, you will also get your answer to be 1.061, where we will divide it by 0.075, and we are getting our answer to be 14.1467. Then from here, you can do the multiplication, and you are getting your answer to be 28,293.4 thousand. So this is the future value annuity for our question, which is A. Then from here, we are going to deal with the B. The B one, we know to say, it is telling us to say how much should be deposited each year if the final value of the fund is 40,000. They have already calculated the future value for us. What do we need to do in this case? So what we are supposed to do in this case, we are finding what is referred to as the annual, where we know to say the future values formula is equal to annual 1 plus r to the power t minus 1 over r, where they have said that the future value is 40,000. So we put our 40,000 here. Our annual is not known, but we know to say this, we are from calculating it from the above. In this case, we know to say this, what is here is also there. So we can just get this and put 14.467. Then from here, we can divide both sides by 14.1467 so that we find the value for the annual. So 14.467. When you divide, you will also get your value for the annual to be 2,827.5145. So this is the value for the annual which we are getting. So I will pause the video so that you can calculate how much should be deposited each month if the final value for the fund is still 40,000. Remember, the B question is different from the C question. Why? Because if you look at the C question, it is giving us how much should you calculate each year, where we know to say the number of compounding periods in a year. You are just putting over 1 on R, of which you know to say any number divided by 1 is that number. But in this case, we are interested in the wordings they have put. They have put each month, so which means the rate is being compounded 12 times in a month. So we will divide this rate by 12, also this rate by 12, and we multiply the time by 12. So this is what I'm trying to say. So if you replace on this, this is the outcome where we said you divide the rate by 12, you multiply the time by 12, and you also divide the down rate by 12. Where if you compute this on your calculator, what is on top, you will get the value for annual being 1.1120646. You divide by, when you divide what is down here, you will get the value for the anode to be 0.00625. Remember, we are finding what is referred to as the anode there. Then from here, when you do your mathematics properly, you will find that you will divide. So immediately you divide, you know, to say it will be anode. The value for your division will be, so you will find your value to be 177.9303. Then from here, since you are finding the value for the anode, you divide both sides by the same figure. In this case, this figure we are from finding, well, you will also divide both sides with the same figure that you are divided the other side, where immediately you divide, you will get the value for the anode being 224.8071.